Welcome. So we're going to go over two problems in this podcast. Right, we're going to go over the information we're given as being congruent, or any information that we would know would have to be congruent using theorems and definitions from geometry. You're going to decide which of the congruence postulate applies, if any, so what type of congruence exists, if any, between the two triangles. And then if you feel the two triangles are congruent, you'll write a congruent statement. Right? You'll do this while you have the tape paused, and then you'll unpause the tape, and then we'll go over the answer, and then you can see how you did. All right, so what type of congruence exists, if any, between the two triangles? All right, so let's see what information we already know. All right, so we're given that OJ is congruent to, I guess I'll write it as MK. We're given that OM is congruent to JM. And interestingly, notice that OM is a shared side. So OM is also congruent to itself. That's not technically given to us, but using the reflexive property, OM would happen to be congruent to itself. Also happens to be congruent to JM, so we do know that, little extra piece of information here, triangle OMJ is an isosceles triangle, because it does have two sides congruent. Do we know anything else? Well, we know that angle KOM is congruent to angle JMO. Right, so those are the things we know. We have four pieces of congruence between the two triangles. You're going to decide is the two triangles congruent or not. Right? So pause the tape, decide on your answer. If you think they're congruent, write a congruent statement, and then unpause the tape, and you can check your answer. All right, so bye for now. Pause me, choose your answer, and I'll see you in a moment. Welcome back, and hopefully you picked an answer. You paused the tape and picked an answer. Right? So let's see. Let's go through our triangle congruence postulates and see if any of them apply. Right? And they're all listed on the side there. I'm going to move this little statement, a true piece of information, but doesn't need to be right there. All right, so let's see if side, side, side applies. All right, do we have three pairs of sides? Well, we've got OJ congruent to MK. All right, so that's one side. And you might think, oh, OM and JM and OM to itself. But actually, this really only counts as one congruence, right? Because it's not congruent to two sides and two separate triangles necessarily, because OM congruent to JM, well, OM is part of triangle OMJ. So is this the OM from triangle OMJ over here? Or is that the OM from triangle, what's the other, what do we call it? Oh, we'll just call it anything. Triangle OKM, right? Is that the same thing? All right, which one are we talking about? So actually, this isn't going to count for three, because you notice here, what's OK congruent to? I don't know. So we don't have three sides in one triangle congruent to three sides in another, right? I mean, we have three congruences listed there for sides, but it's not one in one triangle matched to the corresponding necessarily in the other triangle. One side was left out. OK was left out. So if you said side, 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 sorry, you made a mistake on this one. So it can't be side, side, side. How about side, angle, side? All right, so remember, we need two sides and the included side. Included angle. Right? And actually, next to side, 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 I'm going to write down what we needed so you can see what we didn't have. Why we didn't have what we didn't. Why we didn't have what we needed. So side, side, side was 3 sides in one triangle, congruent to 3 corresponding. I'm going to abbreviate corresponding sides in the other triangle. Right? So the two OMs there didn't count. So for side angle side, we need 2 sides in the included angle. Let's see if we have that. Right? Did we get that? All right. So we have a side. There's the 2 sides in the one triangle, and we do have the included angle. So at least for triangle OMJ, we do have side angle side. Let's see if it worked over here. All right. So here's our 2 sides. Side and side. Oh, but what about this angle? The angle's way over here, right? It's over here. There's our angle. That's not between the sides. So that is not between the 2 congruent sides. So we don't have side angle side in both triangles. So I'm so sorry if you said side angle side, you did not get this one right this time. Angle side angle and angle angle side. Well, both of them require one key thing. We need to have 2 congruent angles and 1 pair of corresponding sides. So let me write, instead of writing 2 congruent angles, that just sounds like we need 2 angles total. But we need 2 pairs, right? 2 in one triangle matched with 2 in another. So 2 pairs of congruent angles. And then 1 pair of congruent sides. And then the placement differs whether it's angle side angle or angle angle side. Right? All right, so, well, I see one pair of angles. We only have here we go, have 1 pair of congruent angles, and 1 is not 2. So if you said angle side angle or angle angle side, we don't have enough angles. So sorry, we got that one wrong. Very sorry. How about hypotenuse leg? We're running out of choices here. Well, the key one, the very first thing, the key piece of information we have to start with to even proceed with hypotenuse leg, we have to have 2 right triangles. If we don't have 2 right triangles, that's it. Hypotenuse leg is done. There is no indication that these triangles are right. We can't look at them and say, is that a right angle? I don't know. Does it look like a right angle to you? No. If it's not given to you, or you cannot prove, not because it looks like it, that an angle is right, and therefore the triangle is a right triangle, you can't use hypotenuse leg. So sorry if you said hypotenuse leg. If, however, you said not congruent, you are correct, right? We don't have information that matches any of the postulates. Now you can't use that as a reason. And you might say, well, why can I use that as a reason? Because I listed all the information above. Right? So if you list all the information, then you can say that too, that you can go through all of the postulates and show that, hey, nothing implies. Oops. Well, my purple is no longer purple, it's black. It's actually probably easier to just do that, and I don't know which one is purple. There we go. We'll keep the pretty purple going. All right, so in this case, the triangles were not congruent. We cannot write a congruent statement about 2 triangles that aren't even congruent. So this one took us a little longer because we had to go through all of our postulates to show the triangles were not congruent. And this one was kind of an interesting problem because we were given a lot of information, just none of it was good enough to show the triangles were congruent. Let's do one more problem and the same thing. So I hope you, if you got it right, good for you. If you didn't get it right, if you understand it now, that's all that matters. All right, so let's try one more, and maybe this one will be an easier one than that one was. And our page will turn momentarily, and here it is. So what type of congruence exists, if any, between the two triangles? This time I'm not going to give you any information except what you see right in front of you. Pause the tape, decide which one applies, if any. So what type of congruence exists, if any, between the two triangles. If you answer A, B, C, D, or E, write a congruent statement and see if you got it right. All right? So pause the tape, come up with your answer, and then come right back. Well, welcome back. All right, so we need to mark whatever information we can. All right, so we can mark, well, let's start actually off with the givens. All right, so we know that AS is congruent to XZ. And that piece of information is given. I'm just going to write it like this, the statement and the reason in parentheses, just because I don't have a whole lot of space. If I move the figure, A, B, C, D, and E go with it. So, and then I have no more space than I had before. The other thing we know is that angle A is congruent to angle X, also given to us. The third thing we know is, it's not marked, but we do know that SZ is congruent to ZS, and that would be the reflexive property. It's a shared part. Now, is that enough to prove our triangle's congruent? It is, but before we can prove our triangle's congruent, in this situation, we do need to say one more thing. I'm just kind of moving up so I can say my one more thing. So, in this case, it was not congruent. The triangles can be proved congruent based on this information. But before I say anything else about the type of congruence, I do need to make one statement, and that is I need to state that triangle SAZ and triangle ZXS. I'm actually going to do that so my Z's don't look like 2's. ZXS, I'll do that everywhere. There we go. Are right triangles. Now, why do you think I had to state they were right triangles? Well, anytime you use this postulate, triangle SAZ, oh, I'm putting it up here. Here, I'll tell you what, I'll put step 5 down there. All right, so triangle SAZ is congruent to triangle ZXS. All right, so that would be the congruent statement, and you could switch those letters around any way you wanted, all right, so long as you matched up the corresponding parts in each triangle. And the reason I can use is hypotenuse leg. Now, just because a triangle is right doesn't mean hypotenuse leg applies, but in this case, this is a leg of the triangle. A leg is any side that's not the hypotenuse. This side here, the shared side, is opposite the right angle. So this is a hypotenuse. So we have a pair of congruent corresponding legs. We have a pair of congruent hypotenuses, hypoteni, I know, whatever you like the plural of hypotenuse to be. And these are right triangles. There's no guesswork here. We are given that angle A and angle X are right triangles. So not only are we given, actually I put that we're given that those are congruent. In actuality, we're not really given that they're congruent. This is sort of an informal proof. But we are given that they're both right triangles, or both right angles, excuse me. All right, so that means in this case, hypotenuse leg does apply, right? And so our triangles are congruent using hypotenuse leg. Thanks for watching these two problems, and bye for now.